Hi, Math 05 students. So today we're going to be working with the quadratic formula. So the quadratic formula is a negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And you can see that printed at the top of your handout. Okay. All right. So the first quadratic formula that we're going to solve is 2x squared minus 5x minus 3. Now, we need to fill in the b and the a and the c, and to do that we use the placement of the coefficients in the trinomial. So this is going to be the a, this is going to be the b, and the c. And the reason we choose it that way is because this trinomial is in the mathematical form of ax squared plus bx plus c. And this is kind of a mathematical formula that you may have seen already as you've done math before this class. Okay, so the a then is going to be the coefficient that's in the first term, which is the 2. So I'm going to write that to the side. A is equal to 2, and b is equal to the negative 5, and c is equal to a negative 3. Okay. All right, and now I'm going to start using the formula. So I've got a negative b, so that means minus a negative 5, plus or minus the square root of b squared, so that means a negative 5 squared, minus 4 times a, which is 2, times c, which is a negative 3, and all of that will be divided by 2 times a, and a was a negative 3. So 2 times, or I'm sorry, a was 2. There we go. 2 times a positive 2. Okay, so now let's go ahead and solve. So we have 5 times 5, which is 25, minus 4 times 2, which is 8, 8 times 3, which is 24. So we have minus a negative 24. The negative 3 was negative. The negative 3 was negative. That's obvious, huh? So 24 minus a negative 24 gives us a positive 49. So that's what's in our radical now. We've simplified everything that was inside of it, so now we have the square root of 49. Okay, 2 times 2 is 4, so we have divided by 4. And then outside here we have a negative times a negative 5, which would give us a positive 5. And then plus or minus 49. This is a little bit joined up there together. Okay, so now we're going to find the square root of 49. So we have 5 plus or minus 7, and then divided by 4. So 5 plus 7 would give us 12. 12 divided by 4 would give us 3. So we have one solution of a positive 3. And I'll write that solution over here so we don't forget it. X is equal to 3. So this time, let's use the negative. So it's going to be 5 minus 7 divided by 4. So 5 minus 7 gives us a negative 2, and that's over 4. A negative 2 over a positive 4 would give me a negative 1/2. So our second solution is x is equal to a negative 1/2. And hopefully you could follow that on the example that I typed up at the top of your handout. Which brings us to another example, and this example is called example 1. It's also going to be using the quadratic formula, so I'll leave that quadratic formula there, but we're going to be using a different trinomial, so I'll erase all of this. So this one's just a little bit different than the last one that we solved. So in this example, our trinomial is actually a function. It's saying f of x is equal to 4x squared plus 2x minus 3. And we're looking for all x's which f of x is equal to 0. So we'll put equals 0 there. Okay, it's kind of close up. Okay, so to solve this, we need to know that a is equal to 4, b is equal to a positive 2, and c is equal to a negative 3. Okay, so we will put these inside the formula. So we've got a negative 2 plus or minus the square root of 2 minus 4 times a, which is 4, times c, which is a negative 3. Okay. So we'll start multiplying the radical. Oh yes, everything then is divided by 2 times a. A was 4, so 2 times 4. Okay. So let's go ahead and start solving this. So 2 times 2 is 4, minus, then we've got 4 times 4 is 16. 16 times a negative 3 would be a negative 48. So 4 minus a negative 48, this would give us a 52. So we have a 52 now inside the radical. So outside the radical, we have a negative 2 plus or minus. So that means it's going to be a negative 2 plus or minus the square root of 52 divided by 2 times 4 is 8. 52 is not a perfect square, but we could factor that to 4 is a perfect square, and 4 times 13. So whenever I'm trying to find that, I always start with the first perfect square, and of course that would be 4. And then, so 52 divided by 4 is 13, so that's how I got that. So now we've got, instead of 52, I'm going to have the square root of 4 times the square root of 13. Okay, great. All right, so study that a minute to be sure you understand that part of it. Okay, so we have a negative 2 plus or minus the square root of 4 times 13 divided by 8. So the next thing we really should do would be to maybe simplify this negative 2 and this 8. So this 8 is the denominator for the square root of 4 and the square root of 13, but we can kind of separate that so that it's also for a negative 2 over 8. So let's go ahead and do that. So a negative 2 and 8 would simplify to a negative 1/4. So now we have a negative 1/4 plus or minus the square root of 4. So let's go ahead and figure out what the square root of 4 is, which of course it's a 2. So we'll erase this. And then we have the square root of 13 right next to it. Okay, so now we have a negative 4 plus 2 times the square root of 13, or a negative 4 minus 2 times the square root of 13. We can still simplify because you can see that 8 is also, if we factored it, 2 times 4. So we're not touching the 4 in the denominator, we're just factoring this 8, so we can also factor it to 2 times 4. And the reason we might want to do that is because that would eliminate the 2's. Okay, so now we have a negative 1/4 plus or minus the square root of 13 over 4. This is where a big board would just be so handy. Okay, I'm going to clean this up just a little bit. Plus or minus square root of 13, and the 13 is over the 4. So basically this is what we have right now. And so our final answer then would be 2 solutions. We would have a negative 4 plus the square root of 13 over 4, or a negative 1/4 minus the square root of 13 over 4. And those are our 2 solutions. And again, I typed this one out because I knew that you might want an example to look at that as I did it on the board. So you have a your turn 1, and I gave you a solution for that at the bottom of the handouts. So I'm going to leave that for you to do on your own, and then that would be a good question to ask me about either in a private Zoom or in our next session on Wednesday. Okay, so I'm going to erase this for now. Okay, I think I'll go ahead and erase this too, just so I have more room. So let's look at example 2, and we have x, and then we have x minus 4, parenthesis, we have equals 3 times 2x minus 9. So this does not look like a trinomial to me at all. Does it look like it to you? No, definitely not. So what we need to do is to go ahead and distribute and then solve the equation, and hopefully it will end up being a trinomial. So x times x is x squared, x times a negative 4, negative 4x, 3 times 2 is 6x, 3 times a negative 9 is a negative 27. And so if I were to subtract the 6x, I have x squared minus 10x minus 27, and that would be equal to 0. So now we have a trinomial that we can use in our quadratic equation. Excuse me. Okay, so I'll leave that trinomial in front of us. So remember that the quadratic equation gives us x is equal to a negative b plus or minus the square root of b squared minus 4 times a times c, and then all of this is divided by 2 times a. So a is going to be, the coefficient's 1, so a will equal 1, b is going to equal the negative 10, and c is going to equal the negative 27. So now that I have that written down, I can erase this and go ahead and plug it into our equation. So we have a negative b, so we've got a negative in front of a negative b, plus or minus the square root of b squared, negative b squared, so that needs to be in parentheses, minus 4 times a times c divided by 2 times 1. Okay. So we have 10 times 10, which is 100. Sorry, there we go. So we have 10 times 10, which is 100. A negative times a negative is a positive. Minus 4 times 1 times 27, a negative 27. So 4 times 27 is going to give us 108. And then times 1 is still 108. So we get a negative 108. So 100 minus 108 is going to give us 208. Or no, it's not. Yes, it is. 1 and 1. So 208. Okay. And we have a negative 10, which is actually going to be a positive 10, and then plus or minus the square root of 208 divided by 2. So let's see if we can do a square root of 208. Oh, I just realized we didn't have minus. Wait a minute. Sorry about this. So 4 times 1 is 4. 4 times 27. Okay, that was 108. And there is a negative sign there. So it should be minus 108. And then we've got minus. Oh, C's a positive 27. Ah, shoot. So no wonder. I wondered why this wasn't working out. Okay, so back to the drawing board. Okay, so we have the square root of a negative 10, which is 100. 10 times 10, negative times a negative. Minus 4 times 1 times 27, which does give us a negative 108. So we have 100 minus 108, which gives us a negative 8. Okay, so we have a negative 8 divided by 2 minus 1. So 2 times 1 is going to be a positive 2. So with this negative 8, we're going to go ahead and factor it. So we get 2 times 4 times a negative 1. And so if we were to separate and factor that, the square root of 4 is going to be 2. So we've got 2. And then we have times the square root of 2. Remember that 1, when it's a negative and it's inside the radical sign, it would be an I. So we have 2 times I. Okay, so now on all of that's going to be divided by 2. Okay, so I'm going to erase this since we've simplified it. So now we have 10 plus or minus 2 times the square root of 2 times I over 2. Okay, so as we continue simplifying, this fraction bar goes all the way to here. So 10 divided by 2 would be 5. So we could simplify that by making it a 5. So now we have 5 plus or minus, and I'll erase that, so now it's just a 5, plus or minus the square root of 2 over 2. And so this 2 could also be simplified. And so now we have 5 plus or minus the square root of 2 times I. And so we'd have two solutions. We would have 5 plus the square root of 2 times I, or we'd have 5 plus or minus the square root of 2 times I. So our two solutions. Okay. All right, and then you have your turn to practice for the second. You try it. Okay, let's see how long this is. So this is 20 minutes. So knowing that a lot of times we don't watch videos that are over 20 minutes, I'm going to go ahead and stop this now. And if you have a question on the your turn number 2 or the your turn number 1, if you're not getting the solution that I've typed out at the bottom, we can work on that together. So just let me know, and I'll be glad to either make another video for everyone to see those solutions, or we can just do a one-on-one if there's just a few of you who have a question on this one. All right, have a good night, and I'll see you when we do the next video.